what type of continuity does f have at x equals 0? Okay. So at 0, this is all that matters. So if you look at this, this is at x equals 0, f of x is 0, right? That's the value. For greater than 0, that's the function. To find its limit from the right, we know x is positive and but getting close to 0. So as x goes to 0, this numerator becomes 3 times e to the 0. What's e to the 0? 1. So that is 3 over 3 minus, so 3 over 2. So from the right, whatever that, however that function looks like, but it is coming closer to 3 over 2, which is 1.5. And on the left, just left of 0, that's the case, so x cubed plus 3. And what happens if you plug in 0 here? 0 plus 3, it is coming to 3 from the left. So it's coming like this. So that's the situation that's happening at x equals 0 and in its neighborhood. So what do you notice here? Is it continuous or discontinuous? So this is a discontinuity. And what kind of discontinuity? It is a jump discontinuity. The actual value is somewhere else, right? So now, no matter where you move this value to this point or that point, it will still remain discontinuous, right? So there's another name for this kind of discontinuity, which is not removable, right? You cannot remove it. You cannot make it continuous by just specifying f of 0 to be this or that. So this is a non-removable. See, I have to go near x equals 0, right? So this is x equals 0, this is x less than 0, and this is x greater than 0. So if you look at this one, this is x is less than negative 2. This is far away from 0, right? It is over here, like from here down is that first piece. So that's not involved in looking at the continuity at x equals 0. It has to be close to x equals 0. Right? I looked at x equals 0, x greater than 0, which is this, and x less than 0, which is that. Okay, then the second part is find all horizontal asymptotes to the graph of f. Show all work that leads to your answer. How do we find horizontal asymptotes? If I gave you, this is a function, f of x, and I asked you to find its horizontal asymptotes, how do you find that? If we have a function like this, right, going like this, then we'll have a horizontal asymptote, right? Or if we have a function going like this, then we'll have a horizontal asymptote, correct? Either you're going towards positive infinity or negative infinity. For finding an asymptote, you have to keep going forever. It's not like at one point. And then it keeps coming close to the line, but it never really touches it. It could go over, it could maybe cross, that's possible, but it doesn't settle on that. So the way you find horizontal asymptotes is you look at, it's also called the end state behavior, which you might have seen before. So x going to infinity f of x, and you look at limit x going to negative infinity f, right? Suppose these limits exist. So this is L and this is M. Then this horizontal asymptote is y equals L, and this horizontal asymptote is y equals M. And it's possible that you don't get a finite number, in which case it's not a horizontal asymptote there. So this is what we have to do. So let's first do limit x going to infinity f of x. So which function will I use here if x is going to positive infinity? The last piece, because that's where x is greater than 0, right? So we have to find a limit for this. See, if you plug in x as infinity, right, then e to the infinity will be infinity, right? What is e? E is a number, approximately how much? 2.718. Okay, e has no relation to pi directly. E is a separate constant. So it's a little bit less than 3. And if you do an infinite power of that number, that will become infinity. So if I do that, then I have like infinity over infinity, which is an indeterminate form. Infinity over infinity, you can't directly do anything. You have to do something and get it into a different form. right? If I plug in infinity, what am I getting here? Infinite, 3 times infinity is infinity, and 3 minus infinity is like negative infinity. This is an indeterminate form. Indeterminate means it could be anything. You cannot tell what it is just by looking at it. Okay, so for situations like this, particularly when we're trying to find limits at infinity, we try to get the infinity in the denominator. Because if you have a finite thing divided by infinity, that becomes zero, right? You take a finite amount and divide it into infinite parts, then each part goes to very small, almost zero, right? So what we can do is we can divide both the numerator and denominator by e to the x. So divide this by e to the x and divide this by e to the x. And you'll see why I am doing that. So what's the numerator now? This cancels out, right? And denominator is 3 over e to the x minus 1. Now can I plug in infinity? What will happen? Because now I have 3 over infinity. So what will this become? Negative 3. So when x is going all the way to the right, then there is a horizontal, there is a limit, right? Finite limit. So one horizontal asymptote is y equals negative 3. This is happening on the right side. Let's try the other side. Limit x goes to negative infinity, f of x. So which piece do we take now? First one, because when x is going towards negative infinity, the first one is in play, right? So x squared plus kx minus 2 over 5x squared. This is a rational function, right? It's a ratio of polynomials. So if we're trying to find limits as x goes to positive or negative infinity, and it's a rational function, then only the highest powers matter. And I can also show you why. But first, I'm telling you that the highest power here is this and highest power here is that, right? When x goes to positive or negative infinity. So it's almost like the other things don't exist, right? So if we had to write it like x squared over 5x squared, then what would it be? 1/5. So the limit here is 1/5. But let me show you how I was showing you here. Like when the limit is x going to infinity, we try to get the infinity in the denominator. So what do? I will write it like this. So what I will do is I divide this by x squared, and I also divide this by x squared. I can do that, right? I'm dividing numerator and the denominator by the same thing. So what does the numerator become? And denominator is. And now if I plug in negative infinity for x, what happens? See k over x, so that is k over negative infinity. What is that? 0. You're dividing a finite number by infinity, right? So this will go to 0. What about this? That's also 0. So that leaves you 1 over 5, right? Which you could have told from here, right? Because of this, when it is rational function, polynomial over polynomial, dividing by the highest power will make the lower power terms go away. So that's why you could have directly written, but if he's asked you to show your work, then you have to do it like this. And this is y equals 1 over 5. So this is the other asymptote. This is the asymptote to the left on the x goes to negative infinity, and this one is on the right side. These are the two asymptotes.